Welcome to the Why Isn't It Working Business and Tech podcast, talking all things business and tech in the emerging and enterprise space. Here are your hosts, Karl Wood and Michael Hamilton.
Hi, and welcome to the podcast. Today we have Mark Pedersen from CTO from KJR. How are you today, Mark?
Hey, good. Thanks, Michael. Great to be here.
Oh, pleasure. And also with me, I have Karl Wood. How are you today, Karl?
Excellent. Thank you, Michael.
Very good, mate. We'll shoot off the first question to Mark. We've got some good topics to talk about today.
Absolutely. Looking forward to this one. So thank you very much for attending, Mark. Can you give us a bit of a background? Obviously, you're a graduate PhD, in the theory of, I suppose, artificial intelligence, although that's a very loose word these days. But so how did you end up joining KJR and driving the technology strategy for them?
Oh, look, like a lot of people. So KJR is a quality assurance and technology advisory firm. Our roots are very much in software testing. And I think, I won't say exactly, but it was back in the late 90s. There weren't many people who were sort of like, oh yeah, I'm going to be a tester. That's my career. But then you've got things like Y2K, etc., raise their ugly head, and suddenly people work out that sometimes there's bugs in code, and in fact sometimes there's really systemic bugs in code. And in fact, the fabric of our society is increasingly built upon technology, and built upon software specifically. So like a lot of people, I ended up sort of falling into that quality assurance space, and sort of to my surprise, I would say, I found that really fascinating. So you've got to think quite creatively, think really laterally and holistically around what are the risks of deploying a particular piece of technology, and how do you actually get the outcome from that whole initiative that you're looking for, so that you're not just wasting money. So for me, that really satisfied kind of like two things: a sense of doing something that makes a difference in the world and makes the world a better place. I mean, I know that every technology person, that's almost a cliche, but at KJR, we actually really believe it. And I think for me, that's how I just kept digging in deeper, and have ended up in the privileged role of being able to sort of shape a bunch of our strategic direction, and sort of shaping the sort of services we offer.
Fantastic. And obviously there's a heavy emphasis on, I guess, like you mentioned, the quality aspects of the thing just working and putting it together. So what is the sort of the goals of KJR over the next couple of years, as an evolution? Obviously, starting from a very humble beginning to sort of, building out now to being a, very well-respected, professional services and innovation company. What do you think the goal is now that you're trying to drive for the next 5 years?
Well, I think over the next one of the things that we have always done is try to keep track of what are the trends in the industry, and I think it is very much a balancing act. There's always the so-called Gartner hype cycle, and so people get very excited about certain things, and it's interesting to see the way that the language changes, and what ends up being a real and genuine genuine innovation or genuine deep change within the industry versus something that is maybe just changing the title of something that has already been around for a while. And for us, we've certainly, there's been lots of talk about AI for a long time. As you alluded, I've been involved in AI for sort of 20 odd years. But for a lot of that time, it's been a research topic, or it's been very niche. And I think we are now seeing something more of a groundswell, and there's a lot of reasons for that, which we can dig more into. But I think for us, as that technology becomes more commoditized, it becomes even more important to then be wrapping QA around that. And we actually started to talk a lot more about validation-driven machine learning in much the same way as, a few years ago, we're also very much champions of, test-driven development or behavior-driven development. So those sorts of approaches to technology which really put quality and correctness of outcomes at the forefront, rather than just like going, oh, we've got a new toy, let's turn it on and see what happens.
Do you think the rise in popularity and I guess now the cost barrier reduction of, COTS and SaaS solutions has forced a lot of companies to sort of shift away from the quality mentality? Like obviously, as we know before, a lot of, software was bespoke, integration was bespoke. Now, we were talked about this in another episode where if myself, Michael, and you went to start a company, we could grab a few things off the shelf, bolt it together, and we wouldn't have this sort of, quality view of it because the assumption would be that it works. Are you sort of starting to see a lot of that in the market as well?
Well, yeah, and I think the interesting thing about that, and I worked on a piece with the Centre for Digital Economy at QUT, and we put together a digital maturity model, which is, I can flick you some links to that. That's freely available, so anyone can grab that report and make use of that questionnaire. But one of the things that we developed within that model, like you see a lot of those maybe kind of more old school capability maturity models, 1 to 5, and it's very evolutionary. We're really thinking about outcome-driven, if you like, value-centric maturity. And one of the things that is often, I guess, inherent in the idea of those capability maturity models is it's linear and it's sort of like from left to right, and you start immature and you gradually become mature. And I think one of the things that happens is that you can kind of stagnate in an area of competence. So you build up a big IT shop, you've got that legacy or that bespoke platform, you've invested a lot of in sort of expertise in the people who are running those servers or running that platform. And then what we've seen recently is all of that disruption of the industry, and you see it in particular in the finance sector, right, where a disruptor can just jump in with some essentially plugging together some off-the-shelf components, and then overtake a much slower organisation that is dealing with a much more complex platform. So one of the things that we talked about in the maturity model is intentionality. So people have a really clear idea of what it is that they're trying to achieve with technology. Will be able to go and select the right components and plug them together, and often achieve a lot more than people who are kind of wedded to being experts on a particular platform, a particular language, a particular way of doing things, and they're unprepared to give up a certain level of competency in order to be more intentional about what they're doing. So certainly seeing a big shift in that regard. There's still plenty of traps in the quality space. So we've seen and helped out some of our clients were early jumping on the bandwagon of digital transformation. And so they quickly plugged together a bunch of different components that were all managed by different vendors that didn't really talk to each other. So the website didn't talk to the mobile app, didn't talk to the in-store platform. And then, trying to do an upgrade, once they were sort of past the initial launch, now we want to roll out a new campaign that touches all of those different platforms. Suddenly it's really hard. Suddenly we've got potential credit card security breaches because stuff that should be masked is now being printed out when it shouldn't be printed out or even available. So there can be some genuine risks that come from trying to build a bit of a Frankenstein solution But I think that's always the tension. In many ways, I see this as just another example of the centralization, decentralization sort of merry-go-round. People will centralize their own bespoke thing, then they'll decentralize out to, COTS or something else. Oh, now these things don't plug together. So there's always a challenge of getting it exactly right.
Yeah, no, it's a good point. I know we discussed previously on other episodes the use of data to make decisions. And I know one of the episodes we discussed the lack of a test strategy in a lot of organizations from the move to agile. It's a common conversation we're hearing. And from that, for me personally, I've used in my career, I've always used the data or the quality data across the SDLC to make decisions on where the issues are. Like sometimes requirements are a challenge because the BAs are challenged because they're time poor, right?
Yeah.
Quality requirements. And that's not having a go at that situation. It's trying to get them all support.
Exactly.
For me, it's making data-driven decisions with data. But the first thing is you've got to get that data, right?
Oh.
And that's the challenge first before we get to those metrics.
Yeah.
Right? Yeah.
Without data, you're just another person with an opinion. So you need evidence, and I think that's particularly true when you are in that quality space, in that testing space. Mostly, the other personalities around you in a technology project will tend to be more bullish. It's all going to work. Let's just keep going. And I think there's I was catching up with one of my colleagues the other day in Canberra, and he was sharing that within his organization or within his client space, his nickname is the Doom Cookie because, every time he turns up, there's just bad news. It's like getting a bad fortune cookie or something like that. But, we take to heart the idea of being truth tellers. Like that's one of our core values at KJR. And I think for us, it's not about just going, oh, it's not going to work. It's like, no, let's have a look at the evidence. Let's understand what the problem is. And whether that's, we did this on one big project. There was basically first release of a large enterprise system kind of failed in UAT. And the client was ready to blame the vendor. And we sat down and did some root cause analysis and said, look, the majority of all of these defects actually originating in requirements, like poor requirements. So then the client took that on board, credit to them for really like going, oh, we need to own part of this rather than just like blaming, the vendor and throwing the toys out of the cot. So they took on board a process where we helped them review quality in their requirements. We weren't writing requirements for them, but we were just doing a review process early on, which actually helped us, plan all of the testing much earlier and much more smoothly. But it also meant that the requirements when they went out to the vendor for development were much less ambiguous, much more complete. There was far fewer assumptions being made on the development side. So second round was just chalk and cheese. Like the client was really happy, the vendor was happy, things were passing through that test process. That was very waterfall kind of days, but I can see the same sort of process is often, just as relevant in an agile setting as well.
And also today, obviously, we use a lot of Jira from Atlassian in that mix, and obviously it captures defects. Obviously, you can capture them across the SDLC. Obviously, test management tools complement that information to get that data, as we mentioned before. But you also mentioned before, also there's QA, quality assurance, and the system, or there's testing itself, the actual software testing phase. Obviously, there's a difference between the two because there's obviously governance of testing of a software project versus non-governance. How do you find those?
And I think that's one of the reasons why we talk a lot about quality assurance is it has to do with embedding like a quality mindset across the whole organization. So if you are if you just talk about testing, sometimes it can be shoved into the back corner of the SDLC. It's something to be circumvented if at all possible. Whereas like I tend to think of quality assurance this is the this is what gives you the confidence to go fast. If you're going, parachuting, did you pack that parachute yourself? Like, do you know that it's actually going to open? If you're driving Formula One racing cars, you really want to know that every component in that machine is working well together and tightly integrated. That's what is going to give you the confidence to push the envelope. So the same sort of analogy for us is, it's like, if you've got an understanding of what your risks are, so that quality assurance conversation, it's about understanding risks, understanding potential impacts, understanding what needs to be tested, maybe also understanding what doesn't need to be tested. Let's drop that out. I've certainly had those sort of conversations where, that's an acceptable risk. We're just going to run with it. If something goes wrong in production, we can fix it fast enough. And in other cases, it's like, no, that would be, significant impact on reputation. But it could have been that the technology side of the business might not have had an appreciation of the reputation risk. So facilitating that early conversation, and, as you say, getting governance across the whole process, so that people can have a robust discussion and argue the point: do we release right now or not? We know this bug is in there. What does that mean? Do we delay? It's much easier to hammer that out if you've got a quality assurance framework and mindset already in place.
And Carl and I will mention, obviously, Wayne. We had Wayne Ariola from the US, who's an evangelist of testing and DevOps and so forth. And the thing is, right, we did agree on something. There is over testing done. Like, I know I've done it myself in the career, because I didn't have the data to reduce the scope, right? And have the data in place to offer that recommendation to do that. It's when you make those decisions or risk-based approach without having the data at hand where the risk goes up, right? And we do. I hear those stories all the time. It's done because they've got to get things into production quickly. For all sorts of commercial reasons, and the risk goes up, and the brand reputation, the media coverage is greatly impacted, of course, with that. But from your perspective now, from probably more modeling of data. So let's say you've got the data, and it could be in whatever systems you've got, JIRA or test management systems. What sort of models, from a technology point of view, would you use to process that type of data and find some insights into that particular area?
Yeah, I mean, I guess it's an interesting thing. Like, to be honest, we've probably not been applying a lot of that kind of fault analysis to test data itself. I think one of the things that's interesting is actually almost what you need is such a large volume of data that on any given project, doing any kind of machine learning on the artifacts that an individual project will produce is really not going to give you the sort of generalizations that are going to be useful for predictions. But if I can use an analogy, because I think we will see this coming in the software world, but if I can use an analogy from the health sector, where I've been doing a lot of work. So one of the things that we've been doing there is building models that are specifically about predicting bed availability in intensive care units. So this is a piece of work that emerged out of COVID-19, out of the anticipation that there might be a very large amount of pressure on intensive care facilities across Australia. So to help with the management of that, we were already collecting a lot of data from intensive care units. This is sort of, just to be clear, there's a separate organisation, the TAWI, that is doing all of that sort of data science. But one of my roles as the CTO at KJR is to provide the quality assurance around what TAWI is doing. So looking at all of the security, looking at all the correctness of that platform. So I haven't been directly building the machine learning models as much as providing all of the assurance around that whole process. But to jump back to the analogy, one of the things that we can do there is collect a whole lot of data from people who've been in ICU, and then what is the outcome? And the reality is this is the pointy end of the healthcare system, and either you're going to spend a few days in ICU and then exit. Unfortunately, some people will not make it, so you are tracking things like mortality. And what you're really interested in is to understand, well, what might be the indicators that are going to give a better outcome for that patient to actually, come out of ICU and recover. But also to understand if there's indicators that it's really not likely that this patient is going to recover. Obviously, everyone will continue to provide best efforts. But if you're looking at a situation where there's pressure or potential pressure on an ICU system, then you want to be able to know what's going to be the availability in that particular ward. Now, very thankfully in Australia, we haven't had that sort of situation where people have been making tough decisions around ICU sort of beds and that kind of thing. But the main point here is that with that kind of medical data, you can track a whole bunch of detailed, heart rate, blood pressure, et cetera, collect all of that information. And then you've also got an outcome. That person recovers, that person didn't recover. As I said, it's a sensitive and sober sort of topic. But building a machine learning model in that space is really like compressing experience. If you're a more junior clinician in that space, it might be hard to make a decision based on what you know when you're looking at an individual patient. If you've been working in that space for 20, 30 years, you might have more confidence, but you still may not have seen more than a handful of a very specific kind of disease. If you can collect data from hundreds, thousands of ICU wards around the world and compress that data into a model, the model's not going to make the decision. A clinician's still going to make that decision. But you can sort of compress the experience of seeing the vital signs and the outcome and the trajectory of a patient from thousands and thousands of cases, and then present that in a way that a clinician can go, oh, how closely does that trajectory match the patient that I'm looking at here? Does that give me more information, more insight, so I can make the best possible decision right now? And I think that's potentially where we might also start to see that happening in other forms of engineering, whether that's software engineering or mechanical engineering, where we can detect across many, many instances the kind of issues, and then start to apply that data to a model to go, oh, I think this is what's going to happen. This is when this component is going to fail. This is when this part of a software process may fail. So long-winded answer to your question, but I think we're definitely heading in that direction. The challenges are very much about how do you collect that data in a format that makes it comparable and usable for that kind of learning.
The other area, I guess, to look at is, like you mentioned before, and we touched on this, which was, artificial intelligence isn't really a new idea. It's been around realistically since the 60s and 70s in white papers, and it's now with computing power, we're able to really harness it. Do you think that a lot of businesses are kind of, diving headfirst into this area without really understanding the application of things like machine learning and artificial intelligence, but, just because it's sort of hot in the market right now? And, how do you guys help guide them through that? Because it's very difficult compared to sort of standard IT delivery, isn't it?
Yeah, it is really different. And I think one of the things that we see is important is that actually, like testing, and that's why we're talking about validation-driven machine learning, becomes much more at the core of what you're doing when you're applying these sorts of technologies. No one's really, very few people will actually write code that is the core of a machine learning algorithm. Like that, that's hardcore research. It takes quite a lot of high-level maths. not in the skill set of most people who are working in a typical commercial setting. But those models are typically very reusable, but they're also highly dependent on the quality of the data that you feed into them. So, 90% of your work or 80% of your work is going to be around just data munging and getting that data in the sort of quality that it needs to be in. But another chunk of it is really going to be around taking a pre-existing model, feeding your data into it, and then trying to evaluate how well does this model actually perform on my data? Because invariably that sort of kernel of a machine learning algorithm will have been trained on someone else's data. And so you're trying to apply that in a slightly different setting. I'm doing this at the moment, models that have been trained on US data. We're trying to do some stuff around privacy. How well do they do at like recognizing Australian place names, or even just, slight differences in, the kinds of first and last names we have in Australia versus the US. Those sorts of things, where those models are still not really universal. There's always something that is peculiar to your own data. So you've got to feed your own data through that and then try and analyze what's going on. What kind of defects have we got here? Is it because we don't have enough edge cases of a particular sort? So there's certain things that that machine learning algorithm is always going to trip up on. And then we also need to assess the impact of that. If it doesn't recognize initials, how is that a big risk? Is that an acceptable risk or not? In some circumstances might be okay. In other circumstances not. If you look at the self-driving car sort of industry, everyone's in a race to build their own system. But for certain things, the data is so sparse that you're seeing the likes of, Tesla, Google, and others sharing data because there's not enough data around like roadside construction. So helping self-driving cars recognize a construction zone and how to navigate it, you need so many examples because they're all really unique compared to what an ordinary bit of road, an ordinary curve in the road or whatever looks like.
Would you find from a software development process that obviously the root cause of defects and when they occurred and what sort of test cases or scenario is pretty much what you feed into a model if you're building one from scratch today? That would be the first place to start, or would you start somewhere else? Or what do you feel are the key ingredients now?
Look, that's a really interesting question because I think the sort of mistakes, and this is one of the things that I find fascinating, one of the sort of mistakes that we would tend to make if you're doing, say, bespoke development, like there's all of the, and I'm going to, exaggerate a little bit here, but there's all of the sort of trivial mistakes that we make all the time, an out by one error, so you just loop too many times, but you got the date format wrong. To be honest though, it's surprising how many times those things continue to pop up. But there'll be similar kinds of really functional sort of issues where you've got the logic kind of wrong. And that's the error. And it could come from, as we've said, requirements. We didn't understand when this record need to be updated. So some, value got overwritten or something like that. So all of those sorts of things that can happen as sort of defects in a typical SDLC, which tend to manifest because when you test, something's actually just doesn't work. A field doesn't populate, a process doesn't complete, an API just doesn't respond. Or if we start getting into, probably the closer thing with machine learning is more to do with like performance issues. So all your functionality is there, it's sort of doing the right things. You've already verified that. But when you start to scale it, then the behavior becomes sort of like non-linear and doesn't work in a way that you expected it to work. And I think that is the sort of thing that you can tend to see with machine learning. You will do your development on a smaller training data set. You've got a model, you've fine-tuned that, you're seeing the right kind of, let's say we're classifying, text or something like that. We're getting the right bits of text are turning up in the right buckets with the right labels, so it's doing a good job of classification. Or we could be doing the same thing with images. The classic, show me all the squares that have got bicycles or buses in. We've all helped machine learning algorithm, do some of that every time we've done a recapture. But so you're ticking the right boxes, but when you start applying like the bulk data that is your real data set, then you might start to see errors, misclassifications, a drop in performance. The question is the problem with the model? Is the problem with the data? Where's that? Where's the issue? And do we need to do better pre-processing before we feed it into the model? Do we need to make the model more robust? That sort of thing is quite challenging.
And with the decision-making process you do for your clients, what are you finding? Do they need speed of their delivery? Is it efficiency? Is it cost reduction? What are you finding the common themes you're discussing, what they need help with majority of the time?
Probably most people, they're like all of the above. But I think speed is always a big driver for lots of people. But I think that there is, thankfully, an emerging clearer view of how to use, say, when we talk about AI, but I think just any IT system really, there is an increasingly more realistic view of what's the problem to be solved, and let's solve that problem, rather than people chasing a sort of a silver bullet. Oh, we're going to put in this thing and it's going to fix everything. So I think that kind of approach where we're sort of really keeping humans in the loop and thinking about what are the outcomes, what are the decisions that we need to make, what's the information that we need, and then how do we get there more efficiently, more confidently. And often that is about speed, but it's also about accuracy, because a hasty decision is one that you then have to go and fix up. It can be very expensive to do that. So that's the kind of conversations that we tend to have, is that people will sometimes be attracted by the hype. They want to be the manager that brings in the new, the hot new thing. But often what we find is that, if people are serious about it and they're investing in it, then they do have a genuine problem to solve. And they're trying to work out the best way to do that. And the sort of questions that come to us is often, can machine learning or some other technology be applied in this way? What would be the risks of doing that? And how do we mitigate those risks as efficiently as possible so that we can just move ahead?
Sometimes it's simple, hey, Karl, is putting data into a pivot table.
Yeah.
Everyone rags on spreadsheets, but they're still pretty valid when they're good, aren't they?
Absolutely. And, that could very well be the piece of advice that we would give, certain clients. It's like, you don't need machine learning for this. Just like, I think we've all sort of like gone, you're talking about blockchain, but do you really need completely decentralized computing platform for this problem? You could probably just have a server. It'll be fine.
Do you think a lot of that, though, Mark, is probably due to the fact that, IT is kind of one of those things where if you look 15 years ago, there wasn't a lot of product marketing, like there were for the big companies. You look at your IBMs and the HPs back then and everything else, and you knew who they were from market dominance. But now I guess there's so many buzzwords and catch cries that everyone kind of feels like if they haven't got their foot in the tech, sector,
Yep.
things like, oh, well, blockchain, no, that's what everyone's doing, so we better get onto it too, because otherwise we're going to fall behind.
Oh, and we're our own worst enemy in this regard, right? Where everyone, as soon as they can, will just rebadge their product as having some element of the, whatever is the latest hype, rather than, stepping back and going, what's the problem to be solved, and what's the benefit of that? And then let's just focus on doing just enough to solve that problem.
Absolutely. And I think that's the biggest thing, where people are sort of, trying to put in a tool set to fix an issue that probably doesn't need it, but it's more either a process or personality driven component. So is that sometimes hard, I guess, Mark, to sort of deliver that news back to, a client to say, well, hey, look, I know this is what you're thinking, but in reality, we've got to solve these issues over here first before we even get to that next step.
Yeah. And look, I think with that, often providing people with the evidence goes back to that sort of data-driven, evidence-driven approach to quality assurance is often really key. Because if I just go, oh, look, you don't need this. If someone's ego is sort of attached to their pet project, they want to do a thing, it's very hard to convince someone otherwise. But I think if you can present people with the data, so if you can say, oh, look, great, you're building this particular, you've got a great idea here, but what I think is really needed is some like end user validation studies. So let's prototype this, let's get some feedback from real end users and then see what their reaction is. And then you decide whether you're going to invest more money in that particular solution. So bubbling up that kind of evidence. And I remember, and this goes back a long way now. So when I was still at lecturing at UQ, we had some students go in and do sort of like an industry placement. And this was at a period of time when the web was new or relatively new. So there was a vendor that was reskinning their very traditional Windows 3.1 style application to make it look like it ran in the browser. They weren't actually using browser technology. They just made it look like it ran in the browser because that was the new hotness. But I was involved in doing some usability studies. So we had the whole one-way mirror, et cetera, and a couple of the execs came down to observe a session, and they had one of their, very typical users. So it was an accounting package. They had a bang on average demographic accounting, like payroll staff person. She was probably in her 50s, I would say, probably didn't have a computer at home, certainly did, used one at work very competently, but certainly wasn't particularly interested in the World Wide Web. So they'd taken away all of the buttons and replaced them with bits of text that were blue and underlined. And it was excruciating for the execs to see someone who knew how to use that package just watching the mouse, like wandering around all over the screen, like going, I don't know where to go, because a bit of blue text with an underline didn't mean anything, didn't communicate, click me. And versus any of us who were like using the web every day, we're like, oh, we'll just do that. So I could have talked to the execs about that, but it was so much more powerful for them to see and have that evidence. So I think when it comes to getting people to really understand what risks are or what's a good use of technology, again, coming back to that QA focus of let's collect some hard evidence and get people to analyze it, or we'll do some analysis, but you get to really look at it. People make their own minds up. And if they're still really determined to go ahead, there's probably nothing that's going to convince them.
That's a good one. Well, Carl asked a good question there. Like, for example, if you do go into a client or a prospect from your perspective and they don't have the data to measure what their problem is in production, let's say there's a media coverage on something that's happened when they've deployed some software, but there's no trail, no audit trail or digital trail, what went wrong. When you say to them as an advisor, by the way, that you need to get that data, what sort of responses have you got?
Yeah, I mean, I guess that's definitely a digital maturity question, and that's one of the things that, you know, when I'm working with people and they're putting in a kind of like a digital transformation sort of program, and I was working with one of the water utilities in Victoria recently, and there was a lot of different, you know, small changes that they were wanting to make that were going to lead up to some big changes. And it was really interesting just to listen to, you know, what the frustrations were internally, and, you know, which things that people didn't like, you know, how much people hate trim, that kind of thing. But you know, one of the real frustrations was around, like, from people who provided customer service. And if someone rang up with a question to do with, you know, planning approvals and things like that to do with water access, then it was sometimes very difficult for people to find plans, find documents, respond in a timely manner. And so, you know, one of my recommendations is really around, let's actually try and track that, because there's a lot of anecdotal evidence from individual customer service people, but there isn't really like actual data to help us diagnose what kind of queries cause problems. Are those problems that really need to be solved? What's the impact on the business and on the customer experience? And there was also, at the same time, people were like, oh, well, we need to redesign the website and things like that. It's like, well, what's that actually going to give anyone? Is it going to just make you look more modern, or is it going to improve the customer experience? Let's do those things together. So as much as might be a drive to do some new thing, I'll always be saying, okay, and let's measure the impact of that at the same time. So if you're going to put one in, you've got to put the other in. And sometimes if the horse is already bolted, it's a much more difficult conversation.
Well, the reason why I asked it was because now that you've got a lot of experience in your career, right, as a byproduct of what you've done to date, and, you know, being CTO, you probably find that you become an advisor as a byproduct of the work you do anyway, with all the data that you collect, all the conversations you have. Are you finding that? And you just, you know, use examples from other clients and other industries to give them insights into what they should do, you know?
Yeah, oh, absolutely. And look, I think there's the individual experience, and that is like, and certainly across KJR, there's people who have much, you know, greater depth of experience in specific areas, that, you know, having them in the room to be able to just go, okay, I've seen this before, it's probably going to be these issues, is really highly valuable. But also collecting, like, continually, for me, I'm continually wanting to collect and collate more data more systematically, because I'm deeply suspicious of my own biases. You know, like, my experience is still just a small slice of the industry. I'll have my own opinions about things. But if we can surface some data from what's actually happening, so that's, you know, that was part of what drove me into building that digital maturity benchmark, etc. Was a way of just collecting some data around what are people doing, what are their experiences. So then as you build that out, people can compare themselves within an industry sector, across industry sectors, in terms of how mature do we need to be in particular practices around digital technology.
And also, being in your position, you're not a part of the furniture. You're coming in from the outside in, and that's makes a difference, doesn't it? Sometimes. Yeah.
Oh, just being able to, and I think one of the things that is challenging, as you say, is that people who are going to drive change and build something, they often have quite compelling personalities. That's necessary. Like, that's not a bad thing. But sometimes within an organization, you can get a degree of groupthink where, people don't want to say no. They might feel like their job is a little bit on the line if they speak up about something they don't think it's a good idea, or something's not working. Even within Datawi, just as a fresh startup, it's funny, those of us who are working in the QA space are quite happy to go, oh, look, here's a defect. But some of the newer joiners who've come from like a data science background or just a straight development background, kind of like reluctant to raise a defect, particularly because it's like, oh, the founder has been writing code on the weekends and I found a defect in it, but I'm shy to tell him about it. Well, the founder for Datawi is also KJR's founder, Kelvin Ross. So he's like, bring it on. I write, there's bound to be defects in my code, so please raise defects. And I think there is that sort of mind shift where you need to give people permission to speak up and go, hey, I think there's a problem here. And I think also coming in from the outside, sometimes that is the role. You'll listen to people on the floor. They will tell me stuff they haven't told their boss. I will write that into a report and their boss will go, oh yeah, okay, we'll do something about that. So that's human nature. It's an important part of, just helping to open up the channels of communication.
Absolutely. And I guess it's not just a problem that's, sort of on the tech sector as well, but it's something that we see a lot across, multiple projects as, from a delivery perspective.
Yeah. Yeah. So, I think that, we sort of started out talking around data and the importance of data. And I think it often, that's still, if you want to think about it more as just evidence and having evidence-driven conversations and being able to, speak clearly about what's really happening and what's the real value and what's the real problem, in a way that, people's personalities will always get attached to, how we do things. That's part of being human. So I don't think we will ever just be dispassionate and make purely rational decisions about things. But I think if we can be informed and passionate, that's when we can build really good technology, and solve difficult problems. And there's plenty of challenging problems to be solved all around us, right?
So basically, get the data, then process it, then make a decision.
Yeah.
That's what I'm hearing today.
But keep the I think keep the humans in the loop as well. There is also that. I think there's still room for a gut feel and for understanding what's important. And I think you've talked previously about. On some other episodes about the challenges with things like bias. And that's why it is really important just to keep the human in the loop in terms of all of these things, is that if you're moving towards a very data-driven, say, machine learning decision support mechanism, if you're just collating data on past, human behavior, well, past human behavior isn't always ideal. There's plenty of bias baked into the decisions we've made in the past. And if we just reinforce that and make it systematic, and, there's plenty of stories, I don't need to sort of detail them, but, bias that gets built into AI systems around, giving loans or, filtering out CVs and things like that. Oh, traditionally men have done this job. You're not a man, so we won't put your CV forward. And so then the human doesn't, the HR person doesn't even get to see that applicant. So that's another part of what we heavily engage in, is not just looking at the data, but also talking to people about, well, what are the values what are the ethics involved? That's really important in the health space. What are the privacy risks and considerations around this? What's the potential impact of a false positive or a false negative? How could that affect someone's life? And let's try and correct for that. So if there's noise in the data, if there's bias in the data, we've got to detect that and then try and straighten it up. And that's as much a part of the process as it is about collecting data. So if we just did the quantitative thing and didn't do the qualitative thing, then we'd also not end up in a good place.
Fantastic. I think it's very, very good advice. Well, it's been an absolute pleasure having you on today, Mark. We really appreciate you taking the time out to, give us your insights in regards to, not just the project delivery, but also some of the challenges that, your clients are facing through, the multifaceted of technology as well. And on behalf of myself and Michael, we also wish, the best for KJR in the future. It's a fantastic company and we'd love to see you guys grow and continue forward into the future.
Yeah, I love chatting with you guys and I'm sure we will continue the conversation.
As always. Pleasure, mate. Thank you.
Cheers.
All right.
All right. Catch you later.